Hey, I am Andrew, and today we want to look at a question which says a metal ball of mass 2 kg and at temperature of 280 Celsius is dropped into some quantity of water initially at 30 Celsius. If the temperature of the mixture is 70 degrees Celsius, calculate the mass of the water, and we are given the specific capacities of the water and metals as these 4200 and 460 joules per kilo per Kelvin respectively. Alright, we are talking about a hot metal being dropped inside some cold water. This metal is hot, it's being dropped into this place so that we have a mixture. The whole essence is that if we neglect the heat loss of the surrounding, we'll discover that the heat loss by the metal ball Qm heat loss by the metal ball is equal to the heat gain by the water, and heat loss by the metal ball is given by the mass of the metal multiplied by the C of the metal into the temperature gradient of the metal, which is from 280 down to 70. 280, sorry for that, let's put in the letters. So temperature of the metal ball down to the final temperature of the mixture. This must be equal to the heat gain by water, which is given by mass of water multiplied by the specific capacity of water Cw multiplied by temperature gradient of water from 30 up to 70. So that is theta final minus theta of water. Putting in the values, we have the mass of water from here, sorry, the mass of metal from here is 2 kg. So 2 kg multiplied by the C for the metal is 460, as we can see here, multiplied by 460 into the temperature of the metal was initially at 280. So 280 minus final temperature of the mixture is 70 equal. Now the mass of water is unknown, so it remains like that. Mass of water multiplied by the C for water is 4200 into final temperature was 70 minus temperature of water was 30. So if we simplify this, if we simplify all this, we have that everything here should give us we're having 193200 equals, this should give us 168000 multiplied by mass of water, and if we divide through by 168000, this will cancel this, and we are left with, still divide this, we are left with the mass of water will be given by 1.15 kilogram. So in a nutshell, the ball loses heat all the way from the temperature of 280 down to 70, while water gains heat from 30 degrees Celsius up to 70. So a combination of the hot metal and the cold water is now giving us a warm mixture of metal and then the water at 70 degrees Celsius. However, we have taken a condition that the heat loss to the surrounding by virtue of heat transfer is being neglected, which in natural sense doesn't hold water, because in natural sense of it, some heat will be lost to the outside surrounding, and in this solution it's not accounted for. So we are assuming that the total heat loss by the metal ball is equal to total heat gain by the cold water. Alright, see you in our next lecture. Thank you.